Hello, welcome to this tutorial video for the OMC-042 data logger. My name is Rob Beun and I'm a sales engineer at Observator Instruments. In this video I will show you how to connect a tipping bucket rain gauge and a 4 to 20 milliamp sensor to the logger. I will also show you how to configure the logger and to get the data from the logger over GPRS to your computer. There's also a introduction video for the OMC-042 data logger, and I highly recommend that you watch that video before you watch this one, because here we go into the technical details right away. For deploying the logger there are 5 steps for first time users. Once more experienced you can take a few shortcuts, but I recommend you start with these 5 steps. Step 1 is to prepare the hardware, the logger, the sensors, connect everything together, SIM card and so on. Step 2 is to configure the logger using OMC Programmer. Step 3 is to test everything in your workshop. See if the sensors, the logger, everything works, and if the communication to your server is working correctly. Step 4 is prepare the logger for field use. And step 5 finally is install everything on site. Okay, step 1 is preparing the hardware and connecting the sensors. At this moment the only thing that is connected is the display. It is connected by RS-232 for both communication in both directions. So because it is a display and it is a touchscreen, you need two-way communication. The activation button is connected to digital input 1. So if you press the button, the logger gets an interrupt on input 1. And finally it's connected by the module power output, the switch module power output from the logger, so you can power on and off the display whenever you want. That's the connections we have at this moment. Now what I'm going to do now is first I'm going to insert the SIM card. The SIM card needs to be inserted with the contact down towards the PCB. So we insert the SIM card. Next I'm going to remove the connectors to connect sensors to it, and then plug the connectors back in. Now the sensors that we're going to connect are tipping bucket rain gauge and a 4 to 20 milliamp sensor. Now the tipping bucket rain gauge will be simulated by just the read switch, the read relay. I'll use a small magnet, and by moving this magnet around the read relay, it will switch on and off, and that will be counted by the logger. The 4 to 20 milliamp sensor, I will use a calibrator unit, because this allows you to exactly see what kind of milliamps are going into the data logger, so we can use it easier to show how everything works. So I'll use this one to simulate a 4 to 20 milliamp sensor. Okay, I'm going to connect the sensors now, but before touching any of the electronics I recommend you use a wristband to avoid electrostatic discharge on the electronics.
To know how to connect the sensors, let's have another look at the pinning diagram. This diagram was already shown in the introduction video. The display is connected to port 2, the RS-232 port. The display is powered from the switch module power output, and it's activated with the activation switch on digital input 1. Now we're going to connect the 4 to 20 milliamp sensor between input 1 and the switched power output 12 volt. So we assume a loop powered sensor, 4 to 20 milliamp sensor between 12 volt and this input. The read relay for the simulating the tipping bucket rain gauge will be connected between digital input 2. Remember, input 1 was used for the activation button of the display. So between input 2 and ground. So it means we switch towards ground, so we need an internal pull-up resistor on this.
Okay, so I now inserted the SIM card. I'll show you in a moment. I connected the 4 to 20 milliamp sensor to the switched power output. Red wire is the switched power output from the logger. Then we get the sensor, so we assume this is a looped powered sensor, and the current is returned into input 1, so the 4 to 20 milli input 1 of the data logger. The read relay from the tipping bucket rain gauge is connected to a digital input 2. Remember, input 1 was already in use for the activation switch, so this one is connected to digital input number 2. I'll show you. It's a lot of wires, but you can see the SIM card is inserted, and you can see the connections of the sensors to the logger. Okay, step 2 is configuring the logger with OMC Programmer. Everything is connected up now, but we still got to tell the logger what to do. To configure the logger, we first need to download OMC Programmer from the website. Then we check if the firmware in the logger is up to date. If not, we upgrade the firmware, and then we do the actual programming. For that, we need to connect the logger to the computer with a USB cable, and of course we need to insert the battery. Then we can do the configuration.
To download software and firmware, please visit our website observator.com. Then go to the Meteo Hydro division, into the tab Support, where you see Software. Below Software you can find OMC Programmer. OMC Programmer is the tool that is used to program all our OMC-040 data loggers. So you can download this tool and release notes here. Below it you see the loggers like the OMC-40, the 042 and the 45. For this demo we use the OMC-042, so you may need to download this firmware in case the firmware of your logger is not up to date. OMC Programmer uses a comport to communicate with the data logger. If you've installed OMC Programmer and you connect the data logger by a USB cable, and of course you insert the battery in the data logger, you will get a comport for communication. You can find out which comport this is by going into the configuration menu, open the device manager, and then you will see ports, and if you open that you will see the OMC-040 family serial port. In this case it's on comport 13, in your particular case it may be another comport of course. Now the first time that you connect the data logger, it will take some time because the drivers have to be installed, so give it a minute or so and then you will see the comport arriving in the device manager screen. By the way, this is all in Dutch, sorry for that. Won't harm you to learn a little Dutch as we go. Okay, so now when we know the comport, we can continue with the configuration process. This is the opening screen of OMC Programmer. There are various options to choose from, but in this case we want to configure a substation or configure a logger, so I select this one. Again, several options. We read the configuration from the substation here, so we read from whatever configuration is in the logger. We use direct communication because the data logger is directly connected to this computer by USB cable. The comport 13 is okay. So OMC Programmer is now reading the configuration from the logger, and we get to see a diagram of the main components that we need to configure. Now if this is the first time that you start using this particular logger, you may want to check the firmware version of the logger to make sure you have the most recent version of the firmware inside the logger before you continue. If the logger is already in use for a certain project and you only want to change some of the settings, it's better to leave the firmware as it is. So only upgrade when you start with a new project, a new application, whatever. Then it is advisable to get the most recent version of the firmware first. To check what firmware version you have, you go to Advanced Config, and here you see the software build. In this case it's version 2, and you can check on our website what the build is at that moment and make sure you have the most recent one. So I click cancel. In this case, if we assume that we have to upgrade the firmware, then you go to main menu. I do not want to save changes in this configuration, so I say no. I go to maintenance, upgrade firmware of the substation, and then you can download the firmware that you downloaded from the website. You can program that into the logger. I'll skip it for now because the firmware version is correct, so I go back to the main menu. By the way, if you do this, normally you will be asked for a password, and you get that password with the logger. So we go back to configuring the substation. We say read configurations from substation again, direct communication from port 13. Okay, and here we are again. Configuration is best done in the direction of the arrows. So we start by telling the logger which sensors are connected to it. On the left you see a list of all possible sensors, all supported sensors, and on the right you see which sensors have actually been selected. The first one, I will not go through all of them, but I will explain the most important ones. The first one is analog differential input. These are the two high-resolution analog voltage inputs that you may remember from the pinning diagram. Analog input are the 4 to 20 milliamp inputs. At this moment one of them is selected. If I go to advanced, you can see that the input number 1 is selected in the mode 4 to 20 milliamp. You can also select 0 to 20, but we keep it at 4 to 20 milliamp input. The sensor power switch is disabled at this moment, but I want it to be enabled. And I want a power up time, a warm up time of 4 seconds. This means that 4 seconds before we take a sample from the sensor, the power to the sensor is switched on. You may remember from the timing diagram that the plan was to use the loop powered sensor connected to input 1 and the switch power output. So the switch power output will be activated 4 seconds before taking the sample from input 1. Okay. Next is a camera. This is you can connect the camera to the RS-232 input for taking a snapshot. Digital pulse input 1 is in use for the activation button of the display, and I want to add the digital input pulse on input 2. I go to advanced and I say I want this on input 2, because here I want to connect the read relay from the tipping bucket rain gauge. This input is connected to an internal pull up. You can also select the pull down, but I keep it at a pull up. So this means that the switch has to be connected between the input and ground. And I'll keep the other settings as they are. So okay. EXO is the multi-parameter EXO sound from Xylem YSI. The generic buses for Modbus, SDI12 and serial, they can be used for connecting almost any sensor that supports one of these buses to the logger. So you don't need a specific driver for it. You can just configure with OMC Programmer the way you want to read out the values from that particular sensor. GPS is for connecting a NMEA GPS sensor. GSM signal strength is for measuring the signal strength of the GSM signal from the internal modem. Internal is a group of internal sensors that you can use, and I will add that too because it's interesting to see. If I go to advanced, in this case by double clicking on it, you see that you can set a battery capacity. In this case we have a battery with a capacity of 13,000 13,000 milliamp hour. So I'll enter that. The battery, each time you replace the battery, you must tell it that the battery is replaced, so it knows that it has a new battery with the full capacity of 13,000 milliamp hours. But I'm now using a battery that's already there, so I use present. So okay. So normally if you put in a new battery, you say that you replaced it, and then it starts counting from the battery capacity. Okay, that was the internal sensor. Then we have the INW sensors. These are sensors for measuring water temperature, pressure, conductivity, dissolved oxygen, and pH. I skip a few. We have several NMEA inputs for different NMEA messages. So these are digital inputs, RS-232 or 422 inputs. We have a few instruments for measuring water current with an acoustic sensor. And down here is the YSI 6 series sondes from Xylem YSI multi-parameter sonde that you can also connect directly to this logger. So at this moment we selected a 420 milliamp input, we selected a digital input, pulse input on input 2, and we selected the internal sensors. So I click OK. So now we've told the data logger which sensors are connected to it. Now we should define which parameters to use from each sensor, because one particular sensor can have several parameters associated with it. For example, the digital pulse input, it is connected to a counter, and at this moment that counter is selected here, so it means that the pulses are counted and the count value is used as a parameter that we can log internally. We could also select like the rates in units per hour, but I will not do that for the moment. I'll just stick to just the counter value. The analog input, if we go to advanced, we see that it is mode 4 to 20 milliamp. You could also select 0 to 20 milliamp, but we keep it here at 4 to 20 milliamp. And you can define a particular range for this parameter. For example, if 4 milliamps would correspond to like 6 meters of water level, you could enter a 6 here, and if 20 milliamp would correspond to 10 meter of water, you could enter a 10 here. So the logger would register values from 6 to 10 depending on the water level as indicated by the number of milliamps. For now, for this demonstration, it's easier to keep them identical. So whenever the current is 4 milliamp, we will register the value 4, and when it's 20 milliamp, we will register the value 20. So you use calculate. 4 corresponds to 4 and 20 to 20. Okay, so that's the easy way. Okay. The analog sensor I showed you, the digital pulse I showed you. Now the internal sensor has a lot of parameters that you can register. At this moment I selected the minimum voltage from the battery, the operating cycle of the processor, so how long it indicates how long the logger has been awake, the processor temperature, and the rest capacity of the battery. Okay. So we told the logger which sensors are connected, and we also told which parameters from each sensor should be sampled. Now we're going to look into the input tag list. Here again you see all the sensors and the selected parameters from that particular sensor. In the log parameter column you can indicate whether or not the parameter should be logged to the SD card, and in the sample rate column you can indicate the sample interval for that particular parameter. So I double click on this one, the analog input. I want it to be sampled at a 10-second interval, for example, in this case. So I select 10 seconds and I say that I also want the parameter to be logged to the SD card. Okay. I do that also for the digital pulse counter. Again, I want a sample rate of 10 seconds and I want it to be logged to the SD card. The internal parameter, I also select a 10-second interval and I want it to be logged. Now I changed this one to 10 seconds, and as you can see, all internal parameters have been changed to 10 seconds because, well, it's one sensor, so they're all sampled at the same rate, but I can indicate individually for each parameter whether it should be logged to the SD card or not. Okay. Please notice that there is a difference between just the sampling and the actual logging to the SD card. The sample interval is now at 10 seconds, meaning that every 10 seconds the value from the sensor is read. And it's also logged to the SD card, but the logging to the SD card is on an own interval, and we will set that particular interval later on. So I click OK. Next one down the line is Substation. And here the only thing you have to do is give the substation a name. In this case it's test 042, which is the name that also appears here. And we just leave it at this, so I click OK. Next we go to data output. Here you can select from this list where you want data to be sent to from the logger. On this side you see which outputs have been selected. At this moment it's the display port and it's logging data to SD card. So the logger will write its data to the display port and it will write its data to SD card. I double click on display port 2 to see what the options are here. Well, one of them is you can select which port, but you may remember that the display is connected to port 2, so I should leave this at port 2. The module power switch means it's enabled. This means that the display is powered from the module power output switch, and you may also remember from the pinning diagram that we indeed connected the power of the display to this output, so we should leave this one as enabled. You cannot change it, by the way, so it's always enabled. The power down inactivity line is something that you can change, but I leave it at 20 seconds. So this means that after 20 seconds of inactivity of the display, the module power will be switched off, so the display goes blank. Okay, so I leave them as they are. Here it is selected to log data to SD card. Double click on this to see what the options are. The rate, the interval is set at 10 minutes. So this means that data will be written to the SD card every 10 minutes. This interval must be an integer multiple of the sample rate. The sample rate, as you may remember, has been set to 10 seconds. So this is an integer multiple, so this is okay, 10-minute interval. Here you see which parameters from each sensor is selected for logging. And you may remember that we configured this previously in the input tag list menu, where you could put a tag on each parameter that you wanted to be logged. So this is okay as it is. I leave it like this. I click OK. Now there's one more output that we want, because now it's only output to display into the SD card, but we also want output to be transferred to our server. And we can do that in different ways, FTP data and TCP data. TCP we will select that ultimately because that is the preferred way of doing it. But I choose FTP data for just the sake of this demonstration. If I double click on FTP data, I can see here that I can set the interval for transmitting the data, and I set the interval at 1 hour. Again, this interval must be an integer multiple of the, well, both the sample rate and the store to SD card rate. Store to SD card rate was 10 minutes, so 1 hour is an integer multiple, so this is okay. I leave it at 1 hour. You can also select the data format from a few options. One of them is native TXT text format, and I will keep that format. You can also use comma separated formats, but for the moment I leave the native format. Okay. So the various outputs have been selected now, and again I click OK. Now, because we want to send data by GPRS, we also have to configure the modem. So we click on this one, FTP and TCP. First thing we have to do is to set the details for the SIM card. There is a list of default values here, and I'll select this one, which is correct for the SIM card that is being used at this moment. But you will have, of course, to fill in the details that correspond to your SIM card, so you may have to get these values from your provider. Next, I have to fill in the details for FTP. I can skip email and TCP for the moment. I just have to, because I selected FTP, I have to fill in the details for FTP. So you need to fill in the name of the server that you want the data to be sent to, the port, the default port is 21, set the mode to active, and then for that particular server, for that particular account, you will have a username and a password, so you have to fill in these values. If you use hosting by Observator, but OMC Data Online Hosting by Observator, then we will give you the value for these, and you can fill those values in. I will do that now, but I will not show you the values that I fill in for obvious reasons. Now there's one more thing we have to do before we can download the configuration into the logger, and that is make sure that the clock of the logger is running correctly. I go to timesync settings, and here make sure you enable the timesync settings with a particular time server. This means now that every 24 hours the logger will synchronize its internal clock with this server. Now, whenever you download a configuration into the logger, it will use the clock from your computer. So make sure that your computer clock is running correctly before you download the configuration. After that, the logger will synchronize to this server if you enable. If you don't enable here, then the clock will be free running after the configuration. So I prefer to keep this enabled. So click OK. And the last thing then is to go into the advanced config, where you can set the time zone of the logger's clock. Here we are in the Netherlands, which means our time zone is Central European time plus 1 hour. So I indicate 1 here. So you have to set this according to the time zone where you want to use the logger. And I don't want to use the summer daylight saving time, so I keep that disabled. Okay. Okay, so what we did is we started by telling which sensors are connected to the data logger. We told which parameters from each sensor should be sampled. We defined which parameters to log to SD card and what should be the sample rate. We gave the substation a name. We told which data output we want, and we configured the modem for sending data to the correct server, and we set the appropriate time settings and time zone. So now we are ready to save the configuration, so we click on Save Configuration, and here we have the option to write the configuration to the substation, so to download the configuration into the logger, or to save the configuration to a file. This is something that you should always do every now and then to make sure you have a copy of the configuration on file. And in particular, when you have the final configuration and the logger is going to be deployed somewhere in the field, then it's good to have a copy of the configuration on your computer. For now, I'll skip the save configuration to file and I will write it to the substation. And here we will see something going wrong, because what happens is that the logger, after a certain time of inactivity on the USB bus, goes to sleep to save power from the battery. So this is a power save feature which causes the logger to go to sleep. So now we will see that the communication fails. And there it is. So failed to receive device system info. Okay, so what I do now is I unplug the USB. See me do it, but it's now unplugged, and I plug it again. This will wake up the logger, so I can now again go to save configuration, write configuration to substation, and this time it will succeed, write successful. Okay, so now normally also save configuration to file, but I will skip that for the moment.
Step 3 is to test everything. You want to make sure that the logger is configured correctly and that the sensors are connected correctly before you deploy the logger in the field. So I use the test setup with the simulated 420 mA sensor and the simulated rain gauge to test everything. The logger is connected by the USB cable to my laptop, and in a moment I will show you the screenshots from OMC Programmer, the actual values menu, where you can see the values that the logger is reading in from the sensors at this moment. You may remember the logger has been configured to take a sample every 10 seconds, and for the 420 mA sensor we programmed a power on delay of 4 seconds. Now if you look at the screen of the calibrator, the 420 mA calibrator, maybe you are able to see it is programmed to give about 12 milliamps to the logger, and normally the numbers are flashing, meaning that the calibrator cannot deliver this current because it doesn't receive any power. That is because the logger is normally switched off. It will not give power to the sensor unless it is powered on 4 seconds before it takes the sample. When it is powered on, you see that the display stops flashing. Then you have 4 seconds that the value is valid. The logger takes its sample in that period, and then the number starts flashing again. So this clearly shows the cycle of 10 seconds in which 4 seconds power is applied to the sensor. The other sensor was the read relay from the tipping bucket rain gauge, and I used the magnet to give pulses to the to simulate the pulses from the tipping bucket rain meter, and we will see on the screen how that increases the counter.
To verify if the logger is correctly reading the values from the sensors, we go into the main menu and then select Read Actual Values. We use direct communication because there is a USB cable from computer to logger on COM port 13. And here we will see the values that the logger is reading from the various sensors, the parameters and the sensors. The analog input is set at 12 milliamps, so that is the value that we are reading here. You also see the counter from the rain meter, which is 71. The counter value is remembered even if you take out the battery. So this value resulted from previous experiments where the counter has been running up to 71. So and these of course are the internal parameters. You see the battery voltage, the operating cycle of the data logger that you can see, by the way. It's incrementing constantly because the logger is on now. Because of the USB connection, the logger is on constantly, so the operating cycle is just increasing in time. If I now move the magnet along the read relay from simulating the rain counter, I move it now 2 times. So we see now at the next update, we see that the counter first, we see the first one, and then we see the next one. So depending on the exact moment where I move the magnet along the sensor relative to the sampling interval, you can see it in 1 or 2 times. So I've moved it along the magnet a few times now, and we will see the update now. Okay, so this menu shows also the relevance of the sample interval. The sample interval, as you may remember, has been set to 10 seconds. So what you see here is that because the logger is on all the time, the sample rate of 10 seconds is active. So every 10 seconds you see an update of the sensor values. So now we know that the logger is correctly reading the sensors. We go back to the main menu. And now we go into maintenance, because what I want to do now is go to the GSM information substation using comport 13 again. Here we can send a test FTP file. This means that we are now check if the logger is able to send an FTP file to the designated server. That succeeded, as you can see here. So okay, go back to the main menu. So now we know that the logger is reading correctly from the sensors, and we know that the logger is correctly sending data to the FTP server. So what I would normally do now is keep the logger running for a little while to make sure that it sends its regular data file as well. So every hour on the hour it will transmit the file. So just keep the logger on for a few hours so you have a few transmissions to your server and check if everything is alright. Now if you go to your server, you will see the files that have been transmitted by the logger. Here you see the file that is transmitted when you send an FTP test message. It's just a text message with just a simple line of ASCII saying date and time, and it's a test message, and that's all. If you look at the messages that the logger sends on a regular basis, so in this case it was every hour, we see a file of this format where you can see well, first a list of all the parameters and their unit that have been measured. Then we see system records. These are records that tell something about the operation of the logger. They don't contain measurement data, but they contain, for example here, the event of power on and the event of starting operation. The D records are the data records. Here you see the timestamp. The year is 15, month 9, day 14, 12 hours, 20 minutes, 0 seconds. Remaining capacity of the battery is this many %. Operating cycle of the processor is this many seconds. Processor temperature is this many degrees. Average voltage of the battery is this many volts. Input current is this many milliamps. Counter value is 62 pulses at this moment. And then the next timestamp is not 20 minutes but 30 minutes, so every 10 minutes a new timestamp. And again the list of parameters and the values of the parameters. You may remember that I showed you here that for FTP data you could select the native mode, native text format, native data format, sorry. You can also select comma separated format here, and then if you look at the file that you receive then, so you save the configuration and you wait a little and then you get the new file on your computer, then you will get a comma separated file of this format. Here you see again the date, a semicolon separates the fields here, the timestamp, semicolon. The decimal separator here has been chosen to be a comma, but you can also choose a point as a decimal separator. So this is the 98.009, sorry, 0.09% remaining capacity, temperature, and so on. So you see all the parameters separated by a semicolon.
We are now ready for step 4, which is preparing the logger for actual deployment in the field. We have to change a few settings before we can do that. One of the important things is the sample interval, and I have to explain first a little bit about the different intervals. The first interval is the sample interval. This is the interval at which samples are taken from the sensor. When you look in the actual values menu, you can see the values that the logger is sampling, and that is done with the rate set by the sample interval. The sample interval is only active when the logger is awake, but in normal use the logger will be asleep all the time, and it will only wake up when it has to store a sample to the SD card. So in this case, every 10 minutes the logger will wake up, then the sample interval becomes active, a sample is taken, and the logger goes to sleep again. So the 10-second interval doesn't really have a meaning at that moment, because the logger is asleep, it doesn't take samples, and once every 10 minutes the logger wakes up, and then it takes one sample. The sample interval is relevant when, as in this situation, the logger is connected by a USB cable and we have actual values running on the computer. Then the logger is awake all the time because of the connection, and then the sample interval is relevant. So for debugging purposes and experimenting purposes like this, it is very convenient to set a very small sample interval so you can quickly see what is happening. But when you go to deployment in the field, it's better to set the sample interval equal to the store to SD card interval. There's no use in having a smaller interval, and it will only consume more power, because whenever the logger is awake, because it is once every 10 minutes to store to SD card, or because it is to do a transmission over GPRS, then the logger will be awake, and in that time it will do a lot of samples. If you set a short sample interval, that will only use power. So for low power, it's best to set the sample interval equal to the store to SD card interval. The store to SD card interval is, as the word says, the interval at which a value is really stored in SD card. All other values get lost. The transmission interval, well, I think that's the clear one. It just means that the values from SD card are being transmitted at that interval, in this case every hour. So now we go into OMC Programmer and we change the sample interval to 10 minutes, if that is what we want in the field. If you want another sample rate, of course you program another sample rate. That's one thing we have to change. The other thing is, you may remember that we programmed FTP. We said that we want to transfer by FTP because I wanted to show you the FTP files. However, if you use OMC Data Online as the receiver, so on the server side you have OMC Data Online running, then it's recommended to use TCP communication. TCP communication has the advantage over FTP that the communication is faster, meaning that it consumes less power to use TCP. Another big advantage of TCP is, if you use OMC Data Online again, that you can do remote reconfiguration of the data logger. So whenever there's a TCP connection, OMC Data Online can grab that connection, can hold it, and allow you to do reconfiguration of the logger from your computer wherever you are. So we now go into OMC Programmer to change these two settings.
Before deploying the logger in the field, there are a few settings that you may want to change. The internal sensors, there was the setting for the battery capacity. Now if you put in a new battery, you have to change the battery into not present, but you change into replaced. I'll leave it for the moment because I did not replace the battery, but if you do, please indicate so that the battery capacity is, the remaining battery capacity is correctly calculated. Then in input tag list, there is the sample rate setting. Now the interval here has been chosen for 10 seconds, which is a short interval, but that was convenient for looking at the actual values, where you can get an update every 10 seconds, so you can quickly see what is happening. But it consumes too much power for normal operation. The store rate to the SD card was 10 minutes, so it makes sense to set the sample rate also to 10 minutes and not a shorter period, because there's no use for that. So make the interval as long as possible, so 10 minutes. So I changed all of these to 10 minutes later on. Finally, data output. I selected FTP data because I wanted to show you the FTP files, how they look like. But as I mentioned before, for the OMC-40 and 42 loggers, if you are communicating with OMC data online, it is recommended that you use TCP for communication. So normally I would have selected TCP right from the start. I only selected FTP to show you the files. But normally select TCP and make the correct settings here. So every 1 hour now data is transmitted, and that's okay. So now I finished all the settings for actual deployment in the field, and I have to save this configuration now to a file and into the logger, and then I'm ready.
Now we are ready for step 5, which is the actual deployment in the field. For that you may need to disconnect the sensors and reconnect them after installing. You may want to take out the battery in between, and after installing everything in the field, it's important that you check with OMC programmer if the current values are okay, so if the sensors are indeed connected correctly again to the data logger. And please also perform a test transmission of FTP or TCP or whatever you are using to make sure before you leave the site that everything is working. As a final remark, I would like to say that this instruction video, even though it was quite lengthy, it only showed some of the features of the logger. There are many more sensors that can be connected, and there are many more features in there, so there's a lot more to tell about the logger, but I can't do that all in a video like this. So if you need any help or advice, please contact staff at Observator. Thanks for your attention.